Okay, Assalamualaikum and good evening. So, I will explain about our assignment given, power and power factor measurement in single phase circuit. So, we were given this circuit for our simulation. So, we need to find current, power and everything. So, for the simulation, we just do this circuit, and then we put two multimeter, one to find a value of current and another one to find the value of voltage. So the assignment given say that we need to find the current and power. This is the wattmeter to find the power. So the second multimeter is to make sure the voltage in the circuit is always 200 volt. So we just start. First we click multimeter, and then the wattmeter. So we will start first the table 1.1, which is this one, the resistive load. So for resistive load, we just need resistor only. So this one, we delete the wire or connection because we just need a resistor only for this measurement in table 1.1. So we run the circuit simulation. So we will have the value. This is the current value across the resistor, which is following the circuit. So this is the power of the circuit, and the power factor is 1. This one we can do calculation and we will get the same answer. This is the important part. We must make sure that the value of voltage always 200 volt in order to complete the circuit. If we get below or over 200 voltage, maybe somewhere wrong. So we use the R1 first, 910 ohm, and find the current and the power. So we will get the answer, and of course the power factor is 1. So next we will use R2, which is 1.8k ohm. So we stop it, change it to 1.8 kilo, then okay. So we just simply run it and we will get the answer, 111.11 milliamp and 22.222 watt. So same for the R3. We will use 3.3 kilo ohm. 3.3 kilo ohm. And also simply run it and we will get the answer, 60.605 milliamp and 12.121 watt. The current value is dropping or decreasing because the higher the value of the resistor, the lower the value of current. And then after finish that, we go to table 1.2, which is resistive inductive. We must use inductor. So go back to the simulation circuit. We add inductor in the circuit, like this. And then we will also do the same thing. First, we must start with R1 first, which is 910 ohm. Sorry. And then the value of inductor two Henry, sorry. For L1, 2 Henry. We start with 2 Henry first. And then we just simply run it and we will get the answer. 343 milliamp, 43.956 watt. So after we will use the R1 value, we stop, and then we use another value for R2. R2 will be 1.8 kilo ohm. And then for inductor L2, which is 3.9 Henry. 3.9 Henry, and simply run it. So we will get the answer 175.3 milliamp, and for the power we will get 22.222 watt. So we continue with R3. R3 value is 3.3 kilo ohm. And for inductor, which is 8.2 given, 8.2, and run it. So we will have the value 88.498 milliamp and 12.121 watt. You see the value of voltage will never change. So that means the circuit is right, because we need to we must make sure the value of it doesn't change. And then after finish with inductor, we will go to table 1.3 is resistive capacitive, the RC circuit. So for the RC, we will do the same thing, but we need to cut connection with inductor, but we use capacitor instead, like this. So for the R1, still same, 910 ohm. For the C1 capacitor, we use 1 microfarad, showing this. So this one we put aside. Sorry. So we run the simulation, we will get the answer. See, the value of voltage never change. So the watt and the current value. So this show the power factor 0.94556. in calculation we will get exactly 1 for the calculation. So next we will use R2 and C2 value. So R2 we will use 1.8k ohm. For C2 we will use 2 microfarad. 2 microfarad. So run the simulation. You will get the answer. 187.7 milliamp, 22.222 watt, and the power factor is 0.59195. And the value of course never change. Next, last one is R3 with 3.3 kilo ohm. And for the capacitor, 3.9 microfarad. 3.9 microfarad. And then we run the simulation. And the answer is this. Current flow is 301.16 milliamp. And the watt is 12.121 watt. And the power factor is 0.2. After all this time, the value of voltage is never changed. Okay, that's all. Thank you.